My name is Rita. I'm a researcher at the Mario Negri Institute, that it's a not-for-profit institution mainly dedicated to research in the field of medicines and health in general. It is based in Milan, in the north part of Italy, and you have probably have heard about it because it's an interesting model for not-for-profit research. As we are researchers, we are very interested in how research is conducted and how we can improve our daily job in doing better research and more relevant and open research. So that's the reason why I have a particular interest in reproducibility and research integrity as a whole. This is my declaration of interest. I'm funded by European Union's funded projects in this period, specifically the Osiris project, that is the one we will discuss today, and projects linked to the European Network for Translation and Research, IATRIS. And I do not have other financial conflicts of interest to declare. So as you are all interested in reproducibility, meta-science, I don't think there is the need of discuss how reproducibility is important for good science, for integrity, and how is really a pillar of research in general. But I wanted just to spend a few words about the definition of reproducibility, because it's something that probably you are aware of, but of course, depending on the context and depending on the scientific fields, this concept, that it's a very complex concept, can be framed in different ways. For the Osiris project, as we are a EU-funded project, we try to follow the definitions from the Commission that has been published in 2020 in a scoping review done by the Commission. And the concept there is really broad. Reproducibility contains a lot of different concepts and different understanding of reproducing, experiment reproducing, analysis, replications, that it's considered the use of different data and to come to conclusions that are more or less similar. But this concept that it's broad and complex, it's and all the different processes that compose the reproducibility are only possible if data and methods are available to people that wants to reproduce or replicate or reuse them. So the idea behind the Osiris project was really to link together the concept of open science to reproducibility in order to produce and test solutions for trying to mitigate the so-called reproducibility crisis. Here you can see that the project is a 4-year project. There are other 2 sibling projects running in the same period, and we collaborate with them because, of course, the issue is complicated and more than one effort is needed if you want to achieve something. But the Osiris project is involved 10 partners from 7 countries, and these are the partners, and L'Oréal, of course, is one of the main partners of the project. As you know, without going into the details, usually the European projects are organized in work packages, and what we will discuss today is linked to the so-called WP3 work package that is dedicated to the development and testing of intervention for researchers and institutions with the goal of improving reproducibility. Of course, researchers are not alone in the evidence generation ecosystem, and other stakeholders play important roles. So another important group is working on intervention for funders and journals, publishers in general, because as you may understand, these stakeholders can really have a role in increasing reproducibility and adopting tools for this scope. So the idea behind these tasks of the OSIRIS project is to create and test evidence-based, usable, and widely supported package of intervention to promote reproducibility. And as we will address primarily researchers and their institution, we started from a proposal of a set of checks, a set of practices covering both what we call methods and computational reproducibility. And then we submitted this set of practices to a broader community. And we will see in the next slides this Delphi study we conducted to really gather information and perspective different from the one of our small network. And this exercise allowed us to obtain a checklist that is now ready, available, but needs a lot of adaptation, implementation, and piloting. And this is the scope of the last part of the OSIRIS project, and we will get some information at the end of the presentation. So basically, in this 4-year journey, you are exactly here. So we concluded the Delphi study, and we are almost ready to kick off the piloting and implementation of the checklist. So this is the content of my presentation. So I will give you some information about the study, the Delphi study we conducted, some very briefly, brief description of the main results, and I will introduce some of the plans for implementation and interventional studies, and this is really a call for you to join us and to collaborate with us if you wish to. So starting from the Delphi study, these are the objectives and the main points of the design. We aimed to develop a core set of items that we thought applied to scientific projects may increase reproducibility, both of methods and results. And we structured this list of items following an ideal research projects. We try to be as much as possible agnostic to scientific discipline. Most of us come from the health and the biomedical field, but we also have in the OSIRIS consortium other researchers active in other fields such as agriculture, soil research. So we tried also to include in our panel people coming from qualitative type of research in order to be able to capture the possible applicability issues across a field. But basically, we started with the idea of an ideal research project. So with the planning of your questions, of your methods, the conduction of the study, the data collection, the data management and analysis, and clearly how you disseminate the results in the different forms. The methodology we followed is the Delphi methodology is one of the most common way to reach consensus on complex issues, and we structure it in 2 online rounds of survey and 1 online consensus meeting. We estimate that 80 respondents would be an appropriate sample size for our precisions. But of course, there are a lot of details about the methodology, and you can find them on the protocol that we publish in OSF. So what we have done in practice, we spent a lot of time, I have to say, to create this panel for the Delphi study because the recruitment of a large and possibly diverse and representative group of people expert in reproducibility is not an easy task, but we were able to address at least 3 of our main groups of participants because we included people doing research, funders, people working in journals and in publishers. And we try to include also people that are not experts in research, but may have an interest in how research is conducted and utilized for decisions. And we were not completely successful because, as you can expect, this is not a really easy topic to discuss with people who are not into the research field, but we had at least a couple of people coming from what we can call public, and we were happy about that. So the survey started with 44 reproducibility items that were developed by the study steering committee, and participants were asked to rate them in the 2 rounds of the online survey in a scale from 1 to 9, and consensus was defined as responses being in the upper third or bottom third of this scale. We also left open the possibility to comment or suggest other items, and we received really a lot of feedback that helped us a lot to slightly revise the wording of items or general comments that are very, very helpful for us in this phase of piloting and implementation. And the consensus meeting was the final event and was needed to discuss those items that did not reach consensus and for clarifying what would be the next step of the project. Okay. Okay, this is the overall flowchart of the study. In the left part of the diagram, you can see the identification and inclusion of participants across the different stages of the study, and on the right side, how the checklist evolved during the different rounds. And we are happy because we achieved our target of people involved in the study. We were able to get the responses at round 1 from 82 people, and we are also happy because the response rate was pretty good in all the rounds. The consensus meeting, you can see it at the bottom of the slide, included only a subset of people participating in the Delphi study. This was obviously needed for feasibility issues because we couldn't run an effective workshop with 80 people connected. So, okay, these are just for your information of the characteristics of the people who joined the panel. We were quite good in representation by gender and stage of career, focusing on researchers. We were less probably good in terms of representation of stakeholder group because researchers, of course, were more frequently represented than other group, and also there was a bit of skewed toward life science in terms of the field of expertise, the field of research, but again, we we were able to include some kind of diversity in terms of field of research. Very quickly, the main results of the study. At the end of the process, 32 items were included, 6 were excluded, and for 7 of them, the group did not reach consensus. And this is the nice picture done by Constant that really drives you into the different stages of the process and the different consensus. As when you see green, of course, item means it is included, yellow is no consensus yet, and blue is exclusion. But I want to show you the results by each section, because maybe it's more easy to read the diagram. For the section on planning, the group was pretty convinced that having a description of the study hypothesis on the rationale and the prior evidence bringing to that hypothesis and how the question of the study or experiment is formulated is important for reproducibility. And also the concept of planning how data are managed during the whole project. And of course, it's not only data management, but also how you plan to analyze statistically your data. So these were the items where the group reached consensus. One important item was excluded, that it's the one dedicated to registered reports. And it's not unexpected, because in several areas, the concept of registered report is still not fully understood or accepted, if you want to say so. And what was a little bit more disappointed, at least for the people coming from the biomedical field, is that the group did not reach consensus on pre-registration. So the group valued a lot the fact that all these steps are predefined, but the concept of making that public is probably for some groups still a bit tricky. For section B, so that was dedicated to the description and the availability of materials and methods, the group was more or less reached consensus very easily. One topic, one item was excluded, but it was considered too specific, and also and it's the one on multiplicity issues, and also covered by a general good statistical plan. There was a lot of discussion about calculation of sample size. At the end, the group reached a consensus, but it's interesting to note how this concept is again perceived differently across different fields of research. Data collection, management, and analysis. Again, here the group reached quite easily consensus about the description of how data are collected and managed, and the metadata to openly and open metadata to be able to understand which data are available and how the data are structured. And also there was a lot of discussion about what we can call items linked to the computational reproducibility. So how you describe the software, or you make reference to a software that you are using for your data analysis, the description of the computational environment, and all the tools and codes that are used along the data analysis. So this is also very much depending on the type of research. Okay, so there was a bit of inconsistency here because probably some items are correlated and some were included and some not. But this is just a matter of, as I mentioned, to refine the checklist and be sure that we include really what the group wanted to include. Section D about dissemination. This is probably the most difficult section we had in terms of reaching a consensus. At the end, the group was convinced about, of course, making all the data and all the results coming from a research project available to other researchers, while they valued less important for reproducibility if data and results are published in open access publication or publication with open peer review. In terms of availability of data, the group reached consensus on making data ready for analysis, ready for statistical analysis, available as soon as, of course, everything is compliant with regulations, if data are considered personal data, or so all the issue about anonymization and pseudo-anonymization. But they decided not to include the availability of the raw data, so the data before, let's say, the cleaning and the modification that leads you to a data set that it's ready for analysis. As I mentioned, we asked the panelists also to provide comments, and we analyzed these comments using some qualitative methods. And I won't go into the detail of that, but just to mention that these comments, most of these comments were really, really helpful for us to shape the discussion during the consensus meeting, because some themes, broad themes, were really frequent in the comments. So we decided to dedicate a part of the consensus meeting to discuss these themes. And again, very quickly, but this is the main these are the main messages that came out from the meeting. So for whom the checklist have been developed, because the group recognized that there was a lot of variability in the perspective. So some groups, for instance, a funder may be interested in the planning phase only, because this is the information that is available at the time of funding proposal submissions, while editor or a peer reviewer could be more interested in the dissemination part, because it's really the part that affect and it's more closely linked to the publication of results. So depending on the type of users, and also depending on the stage where you would like to apply the checklist, maybe some items are more important than other, or more not maybe important is not the right word, but more actionable, let's say. And there was also a lot of discussion about how to adapt checks to confirmatory research or basic research, clinical research, or public and private research, depending on also the possibility to open up the materials, or so again, open science and open material was really one of the key points for this discussion. And also a lot of needs emerged from this discussion, and these are really the foundation of our implementation and piloting phase. So the need for explanation documents and guidance on how to use the checklist, training and education in general on reproducibility, and specifically on the items we included in the checklist, and the importance of piloting. So making this checklist available to different communities and try to test the the checklist, if it's really effective in detecting reproducibility issues, and also if it's applicable, because if it's not applicable or it's too demanding, of course, nobody will use it, and it's an effort that lead to nowhere. So this is really what we are doing now in the project. So we are focusing on in context, implementation, guidance, and training. So just a few words on the ongoing activities in terms of testing. Probably, yeah, this is the most relevant piece of research we are doing. It's a randomized control trial embedded in a cohort of preprints. We want to test if a subset of these reproducibility checks, those more closely linked to open science, are effective in increasing the reproducibility of research. So the idea here is to randomize preprints, so public documents which are still let's say in a phase where constructive feedback and constructive comments can lead to a change. And half of the preprints in the study will be subject to a reproducibility check, and very detailed report will be sent to the authors, while the control group will receive a generic information about integrity and so on. So the idea here is to measure if this check really leads to improvement in terms of open science and reproducibility. And the trial will start very soon, I think. Constant is in charge of it and is working hardly to make it started. And of course, both the reproducibility checks and the assessment of the outcome of the study will be done by reviewers. So it's very important to have people, and people can join this group if they want. Here you just see the link to the reproducibility network. I know several of you are already in the loop, but if someone is still not registered into this Osiris reproducibility network, it would be great to have you too. The second example I would like to give you is a collaborative pilot of the checklist we would like to do in one workshop in Berlin. The idea here is to convene another group, so an independent group of researchers, independent from the one who developed the guideline, the list of checks, and try to apply the checklist to real papers and real projects. And we want to do that in different scientific fields in order, as I mentioned before, to study the implementation in various contexts. The output of this workshop would be a better explanation of each item to support the use, and possibly some concrete example on how to apply the checks. And this will be done with a co-development with the participant to the workshop. The workshop will be in Berlin in September, and the announcement will be, I think, ready soon. But for the moment, what you can do is go here at the unconference website and get some more information about this very nice format for conferences where nobody, let's say, talks like me for 20 minutes alone, but there's a lot of collaboration and a lot of really exchange of ideas in this project. So again, if you are interested, we can send you the clear information as soon as is available. It's in September and in Berlin. The third and last point is about training. The Osiris project has a dedicated group that is now actively working on training about reproducibility. The first part of the project was dedicated to mapping the needs, and this is more or less done. And the second part will be on development of prototype training materials and user testing. And again, here, the idea is to co-create this kind of material with participants to workshop. One workshop will be dedicated to researchers. So again, if you are interested, just contact us, and I think it will be great to have you on board on these type of activities. Okay, so I think I've more or less told you what I had in mind. The conclusions are really simple. So we developed these list of checks. We are happy that that we were able to gather an international and multidisciplinary and somehow diverse group of experts in this exercise. That was a really an interesting experience, but the journey is not finished yet. We still have to make these list of items actionable, and we want to really understand how to better frame them across fields or across type of user. So this is our plan for the next year and a half, I would say. So if you want to be part of that, we will be super happy. My last slide is dedicated to the Osiris WP3 Dream Team. These are really excellent collaborators. I wouldn't be able to deliver this presentation and anything without them. So thank you guys a lot, and thank you for your attention.